Page 60 is radical expressions. Flip on over to 57 for our objectives. Our Unit 7 objectives. Today we're going to talk about simplifying radical expressions. And we're also going to talk about simplifying fractional radical expressions. This will be a two-part lesson. Today focusing on the basics and the steps. And then tomorrow we'll add another step and work from there. So, page 60. Radical expressions. Page 60, radical expressions. So a radical expression, the definition of that is an expression that contains a radical sign. So an expression that contains a radical sign. Now, when we're working with radical expressions, we're going to have 4 steps to follow when working through the problem. So the first step that we need to think about is if there is an expression in the radicand, we need to solve it. So what is the radicand? The number that's below the radical symbol or the number that's inside the radical? Good, Jonathan. Jonathan. Take it off your desk, please. Thank you. Okay, so we're going to solve the expression in the radicand if there is one. From there, we are going to take the root if it is perfect. So take root if perfect. So step 1, we're going to solve expression in the radicand if there is one. If there isn't one, our first step would be to take the root if it's perfect. But if there is an expression, we solve it, then we take the root if it's perfect. But if it's not perfect, so step 3, if not perfect, we're going to factor tree. So we're going to use our factor tree method to find the factors that we'll be able to pull out and use to simplify our radical expression. So we're solving expression radicand, taking the root if it's perfect. If it's not perfect, we're going to factor tree. Once we've gotten to the factor tree, we're going to pull out pairs of numbers or variables. Numbers or variables. So the reason why we're pulling out pairs from square roots, somebody who can tell me that? How do you find the square root of something? Or what is the square root representing? So two numbers multiplied by itself. Very good. So we're going to pull out pairs of numbers. So pairs numbers mean that they're the same number. So we're going to pull them out. So that number will be able to be a perfect square. So we're able to take the square root of it. So let's work through a couple examples to see what this looks like. The first example we have is the square root of 3 squared plus 4 squared. So what is 3 squared? 9. What is 4 squared? 16. So we've done step 1. This one had an expression in the radicand, so we solved the expression, or we're working on solving the expression. So we keep the square root with it. 9 plus 16 is 25. Keeping the square root with it, what is the square root of 25? Is it perfect? It's perfect. So the square root of 25 is 5. And there is our answer. So we solved our expression in the radicand, and then we took the root because it was perfect. Let's try another example. Let's say we had the square root of 5 squared plus 12 squared. So what's our first step? So we're going to solve the expression first. So 5 squared is 12 squared is 144. So 12 squared is 144. 5 squared, 25. So 25 plus 144 is 169. Is 169 perfect? If we don't know, how can we check? We can use our calculators. So pull your calculators out. Silence that, please. How'd you get that, Spencer? So, you guessed because 12 was close? So 12 squared is close? That's good. That's one way to think about it. So if we don't know and we don't guess right, we can go ahead and hit second, the button on the top left, x squared. And that'll pull up our radical or our square root. And then we can go ahead and punch in 169 and hit enter. And it is 13. So second, x squared, plug in our number for square roots. So we get 13. Let's try another one. Let's say we had the square root of 4 times 16. What is 4 times 16? 64. Is 64 perfect?
Yes.
What is it? 8. 64 is 8 times 8, so the square root of 64 is 8.
Can't you go like further?
So now we've done ones that worked out perfectly. Let's take a look at a different kind of example. Let's say we had the square root of x minus 5 squared. Is there a trick, or does anybody notice anything that might be convenient about this problem? Stephanie. So x minus 5 is already squared. So squared and square roots do what? They cancel each other out. So the answer for this problem will be x minus 5. There's something special that has to be out about this x minus 5. Can you take the square root of a negative number? So what do we need to put around x minus 5? We can put parentheses around it. The absolute value. Good, Jacob. You have x minus 5 in parentheses squared. So squared and square root cancel each other out, right? So we're left with x minus 5, and Jacob said we need to have the absolute value of x minus 5. Why is that, Jacob? So you can't take the square root of a negative. It's imaginary. So very good. So now we've had all these examples that work out conveniently and perfectly nice. So let's have one that doesn't off the bat. So we have 125 as our number. The square root of 125. Is 125 perfect?
No. Yes. No.
It's a perfect cube. Is it a perfect square? No. So what are our factors of 125? 5 and 5 and 5, or 5 and 25. So we have 5 times 25 is 125. Can we break down 25 more? 5 times 5. Bless you. So now we've factored it completely. We're going to go ahead and circle our pairs. So there's a pair of 5s, which means 5 times 5, right? Or 25. Square root's a perfect square, right? So when we have a pair of numbers, we pull those outside of the radical. And we leave what's left, this extra 5, in the radical. You could have noticed at this step that 25 was a perfect square, and then simply taking the square root of that and putting the 5 outside. Or it's perfectly fine to finish the factor tree and get all of the factors and then circle the pairs and pull one out. So anything you circle, you take one of them out and put it out front. Anything that's left, you leave under the radical. So let's try another one. So let's say we had the square root of 48. Is 48 perfect? No. Is 48 a perfect number?
No. Who said yes?
So what factors of 48 are there? There's 1 in 48, there's 6 and 8. What else? 4 and 12. 24 and 2. 3 and 16. So let's go ahead and say we just went with 2 and 24 because that's all we could think of. Is 24 perfect? How can you break down 24? You can do 2 and 12. Is 12 perfect? You can go 2 and 6 and 2 and 3. So now, what do we factored it completely? What do we need to do? Circle our pairs. So how many 2's am I going to put out front?
4. Well, 2 pairs. 2 pairs is 4.
There is 2 pairs, but what do we know about pulling it out? We have 2 times 2, right? Which is 4. So the square root of 4 is 2. So we pull 1, 2 out. We have 2 times 2, which is 4. And the square root of 4 is 2. So we're going to multiply those two numbers together. And what are we leaving in the radical? This 3. Which simplifies to 4 square root of 3. Here's a trick that we can use using our factor squares. So go to page 2 and think about, go to number 48 and look at its factors. We have 2 and 24, which we used, 4 and 12, which we could have used, 6 and 8, which we could have used, but none of those numbers were perfect, right? We have 3 times 16. Is 16 perfect?
Yes.
What is the square root of 16? 4. What's left? 3. So we had 4 radical 3. So we can use our factor square anytime you get to a number under 100 and look to see if any of its factors are perfect squares. Or you can it's totally fine to do the factor tree. This is just a shortcut if you choose to use. Let's try another example. Let's say we had the square root of 180 x to the 4th. Is 180 perfect? What are its factors? We can do 90 and 2.
60 and 2.
We could have done 60 and 3. We could have done 9 and 20. So we're breaking down 90 and 2. Is 2 perfect? Is 90 perfect? No. So how can we break down 90?
30 and 2.
Let's think about it. Let's go to our factor square. Are there factors of 90 that have a perfect number in it? 9 and 10. So 9 times 10 has a perfect square in it, 9. We can break that down to 3 times 3. So we have a pair, and we circle it. Then we have this 10. How do we break down 10? 5 and 2. Hey, look, that gave us another pair. So what are we going to pull out so far? How many of each?
1 of each.
1, 3. And we're going to multiply that by 1, 2. Now we have to deal with this x to the 4th. How can we break down x to the 4th? X squared times x squared. They match, right? So now we're going to multiply that by x squared. And what's left? That's square root of 5. So 3 times 2 times x squared is 6x squared, square root of 5. Yep. So that is our final answer. Do we need to see another example? So we're good to start our homework. Get a piece of paper out. I'll put your homework on the board.